do those look like? Well, if you have two interval ratio level variables, like height, you see down here on the what we call the x-axis, and self-esteem on the y-axis, this is how you can show visually the relationship between those two variables. Each one of these points in the scatter plot, this visual is called a scatter plot. Each one of these points represents one of our subjects, one of our cases. And you see that I've drawn a line, tried to draw a line through all the points in the scatter plot to show the relationship between these two variables. And it's this line that's going to have the R, Pearson's R, associated with it. So these are all our dots, and this line would represent a positive relationship, meaning as height goes up, self-esteem goes up. So as one's height goes up, self-esteem goes up. So the R is going to be positive, and it's probably, this line probably represents an R greater than 0.5. Let's say it's 0.6. An R of positive 0.6. I just made that up. So it's a fairly strong relationship, and it's positive. As height goes up, self-esteem goes up. Let's look at some more examples. Scatter plot. Okay. So recall that you use a correlation to describe the strength and direction of the relationship between two variables. Let's look at these examples. These aren't really scatter plots, these are correlation lines, but let's pretend that there are data points all around these lines. These would be the data points from our subjects. Same thing on all these examples. Okay, so what might the R be if you saw a scatter plot that looked like this? Well, it's an inverse relationship, because as you go up on the x-axis, you're actually going down on the y-axis. It's an inverse relationship, so it's negative. It looks fairly strong here, so I'm going to say it's, and this is arbitrary, I'm making this up, but it's fairly strong, and you can basically eyeball that line. Let's look at, okay, this will be scatter plot A, and this will be scatter plot B. Okay, what do you think about this line? Well, as the x-axis goes up, the y-axis, the dots on the y-axis go up slightly. So we can tell that the R is going to be positive. It's a positive relationship. But the line is not very steep. That's the word I was looking for. So it's a fairly weak relationship, and the R is probably closer to 0.3, positive 0.3. Okay, what do you think about this example? These are the dots, and that's the line drawn through the dots, or the points. As we go up, as x goes up, our y is also going up, and so we know that our R will be positive. It's a positive relationship, and it's a very steep line. So it's probably going to be a very strong relationship. I'm going to say it's 0.8. I'm making up the numbers, but you can tell by the slope of the line whether it's strong, or the steepness of the line, whether it's strong or a weak relationship. Okay, on this last one, scatter plot D, we have a straight line. What do you think the R would be? Is there a relationship? Are they related at all? As X goes up, Y doesn't change at all. So if you saw a scatter plot that basically looked like this, you could say that R would probably be 0. No relationship at all. Same thing with a scatter plot that would just have a complete vertical line. R would probably be 0. As Y goes up, X doesn't change. No relationship. So those are some examples of visually representing correlations between two interval ratio level variables. The next thing we'll be talking about is how to read or how to interpret results from, let's say, an analysis between variables. This is actually an analysis from an SPSS, and what you can see in SPSS in the results, it's called Pearson correlation. It gives the n, so it gives the sample size, and it also gives whether or not that correlation is significant. We'll talk about significance more in Module 10, so let's kind of ignore that for right now. Let's look at the relationship between a student's ACT reading score, okay, ACT reading, this is a matrix, so you can disregard the ones down the diagonal, because that's just looking at the same variable. I mean, you would expect the ACT reading score to have a Pearson correlation of 1 with this ACT reading score. That's perfect relations, perfect correlation. You expect that. It's the same variable. So let's look now at ACT reading score and ACT English score. The R is positive 0.646. So it's positively correlated, meaning that as ACT reading score goes up, ACT English score goes up. Let's look at ACT reading and ACT math. Positive 0.556. Again, as ACT reading score goes up, ACT math score goes up. Just looking at the relationship between these two variables. Let's look at ACT reading score versus college GPA. Again, the Pearson R is positive, meaning that as ACT reading score goes up, college GPA goes up. Now, out of these three, though, what has the strongest correlation? It's the highest number, the 0.6. This is the weakest, this is a weak relationship, 0.25. That's how you can interpret the Pearson R, or the correlation coefficient, in an SPSS printout like this. Let's look at something different. Let's look at ACT math. The Pearson's correlations are a little different across. This one, of course, is the same as this one. We already looked at that relationship. But ACT math with ACT English, positive, but only a moderately strong relationship at 0.5. Again, ACT math with college GPA, still positive, but a weak relationship at that 0.2. There are no inverse relationships identified or represented on this matrix. If we had an inverse relationship, the R would be negative. So on this entire chart, basically we're looking at the correlations between 4 different variables. On this whole entire chart, the strongest relationship is probably this one that we have boxed, 0.646. The weakest relationship we see on this chart is this one probably, the 0.245, college GPA with ACT English. So that's how you can interpret the Pearson's correlation on an SPSS printout. So as a recap, with descriptive statistics, we've been looking at answering a few of these 5 questions. We can answer question 1 with descriptive statistics, question 2, and question 3. Descriptive. We can look at in the bivariate relationship between 2 variables, bivariate. With inferential statistics in Module 10, we're going to take a closer look at magnitude. Can we generalize? Can we infer from our sample to our population? Can we make predictions given the value of our variables? Now we will be practicing. Thanks.